And welcome back. So now we want to talk about the inside of the sun. And in order to do this, we're first going to talk about the inside of the Earth. So if we go back to unit number 2, when we talked about the solar system, we said that the Earth had a inner core composed of solid iron and nickel. It was then surrounded by a liquid outer core of iron and nickel. It was then surrounded by denser rocks, which we called the mantle, and then that was surrounded by a very thin layer of crust that was composed of not so dense rocks. So the sun is very similar in that the sun has different layers to it. So inside the sun, you're going to have the core where nuclear explosions are occurring. Okay, then surrounding that is going to be a layer where the heat is traveling to the surface of the sun in the form of radiation. And then on top of that is another layer where the heat is moving towards the surface in convection currents. And then on top of that is a very thin layer, kind of like the crust of the Earth, and it's going to be called the photosphere. And then further out is going to be called the atmosphere of the sun, and that's going to be the chromosphere. And then finally, you have the corona, which then transitions into the solar wind. So you got all of these different layers that correspond to the sun, just like the Earth does. Okay? How do we know? So let's go back to the Earth. Do you know that we've only drilled into the actual crust of the Earth a few kilometers, a few miles? But yet we say that the actual size of the Earth is thousands of kilometers deep. And we say that we know all the different parts of the inside of the Earth, and we know what they're made of, we know what state that they're in. How? So we've never physically touched the inside of the Earth, but yet we think we know what goes on inside the Earth. So how do we do it? So this isn't going to be on the Unit 3 exam, but it's worthwhile going over this. So for example, we know the composition of the Earth. We assume that it's the same as an asteroid. So an asteroid is made mostly of iron and nickel with some rock that goes with it, made of silicon and oxygen, and a smattering of other elements. So that's our starting point. We think that the Earth has the same composition as an asteroid. Okay, then the next thing is, how do we know the mass of the Earth? So again, we have to assume. So if we know the size of the Earth, we know the radius of the Earth, and if we know the density, approximate density of the Earth, and we get that by knowing that the Earth is composed of iron and nickel with a smattering of other rocks, we can now figure out what the mass of the Earth is. Okay, now the next thing is, how do we know, or what is heating the inside of the Earth? So we assume that the Earth was initially hot from the impacts of its formation, and also there is nuclear fission going on inside the Earth that again generates more heat. So we have an idea for how hot the inside of the Earth is. Okay, then how do we know the density at different depths, the pressure at different depths, and the temperature at different depths? Well, all of this would be predicted by chemistry. So that's how we know that the Earth has all these different layers and what those layers are composed of and what the state of those layers is. Are they solid, liquid, or something in between? Could we do the same thing for the sun? So we're just not making up the fact that the sun has a core and then a radiative zone and then a convective zone. So we have to have some proof that the inside of the sun is what we say. So we're going to do the same thing. what is the overall composition of the sun? Well, we think it's this thing that's going to be called a nebula. So if you recall, back in unit number 2, we talked about the nebular hypothesis, which was that the Earth begins as a big cloud of material that collapses and then begins to spin, turns into the disk. Okay, so we think that that's related to the origin of the sun, that the sun begins as this big nebula, this big gas cloud. And so we know what a typical gas cloud is composed of. Okay, the next thing is, how do we know the mass of the sun? Okay, this comes from Kepler's third law of motion. So that was the one that said that the period squared was equal to the semi-major axis cubed divided by the total mass, the mass of the planet plus the mass of the star that it was going around. So if we know the distance from the Earth to the sun, and we know how long it takes the Earth to go around the sun, then we can figure out what the total mass of the sun plus the Earth is. And then by knowing where center of mass is, we can actually figure out the mass of the sun. All right, now the next thing is, what is heating up the sun? So we think it's nuclear fusion, hydrogen being converted into helium. So that's going to be the energy source for the sun. So now what we've got to figure out is, what's the pressure like, and what's the temperature like, and what's the density as you go deeper and deeper inside of the sun. And this is going to be predicted by these things that are going to be called the equations of stellar structure, which I'm going to just show them to you. We're not going to do any calculations with them, but I just want to show them to you so that you can believe with certainty that we're not making stuff up when we say that this inside of the sun has all these different layers. And so I will show you the equations of stellar structure in the next segment.